Hello, welcome to my video demonstration of the BopIt design exercise. First things first, we'll take a look at some of the code I wrote. So basically, two scripts again. One is an Arduino C++ script to run the game on the embedded system, and then the other is a Python script that's living on the server that's queried. We'll see that in the C++ script. That's queried to grab the SQL database. So essentially, it's a state machine. I have 7 different states that we go with. 4 of them are the different actions we want to take. One of them is we're waiting to start a new game. One of them is we have lost, so now we need to query the SQL database. And the last one is transition, which is a pretty big design decision. So basically, I realized when you're shouting, for example, if you immediately transition from the shout to the bop, it's going to register that you're still shouting on the microphone because you're still making noise, and that's a problem because then my code will detect that you are shouting and not bopping, and therefore you should fail, and you'll instantly fail. So this transition is designed to help kind of say, okay, you got the point, now stop shouting, so that way the system isn't kind of overwhelmed. Some key stuff in the code. We basically have 4 functions that lived outside the loop. Basically, we're constantly checking: is this bopped? Are we shouting? Is the device being tilted, or is the device being spun? For tilt, I use the accelerometer. Just ran an average filter, really over the last 5 values, and basically said, okay, what we're going to detect is based on geometry and how gravity works. When we tilt when we tilt 30 degrees or greater, we're going to make essentially a triangle, and the acceleration due to gravity in the x or the y directions is going to be equal to 0.5 times the hypotenuse, which is 0.5. So that's basically what we're detecting here. If we're basically saying, oh, for the last 5 times that we're detecting, is the effect of gravity in the x and the y or the y direction significant? And if so, then we are tilted. For spinning, similar thing. We're basically doing an average filter, doing an averaging filter over the last 50 reads, and multiplying by the time since over that time. So it's a discrete time integration to determine the degrees, because the gyroscope gives us degrees per second. So discrete time integration will give us total degrees spun. So that's kind of what's going on there. Last part is the SQL query. Kerberos is pre-programmed. You can change that. It'd be very difficult to change on the machine, so it's easier to change just in the script itself. And yeah, so that's pretty much the brunt of the code, I guess. With the loop, we're basically going through a state machine, and with the different cases of what's going on, we have different behavior. But the 4 states for each of the behaviors is we're checking all of those 4 helper functions. And saying, okay, if the proper one is called, returns the true flag, great, we're moving on, you got the point. Otherwise, we lost or transitioned to a lost state. So let's see it in action. It's going to be kind of difficult with one hand, but we'll do our best. All right, so to start, as requested, you press the button. I can't read that. Tilting, spinning, sorry about that. Okay, so start the game. Shouting, tilting, bopping, tilting, bopping, tilting, shouting, spinning. Yeah, so that's kind of the general game. I guess I must have gone too slow on that last spin. And you can see here's the SQL output of the scores. So earlier today, I got pretty darn good at this game, apparently, and hit 23. I don't see our score. I guess it didn't make it onto the top scores, unfortunately. But hopefully next time. That's most of the implementation. I'll write up some details in terms of what I did in the coding to make it work, but hope you enjoy.